This episode is sponsored by DataCamp. You can start building your data science and analytics skills by clicking on the link in the description. Every year, thousands of tons of space debris rain down on Earth. Most of that material is so small it gets totally vaporized when hitting the atmosphere. But occasionally, a chunk will survive its fiery descent, falling to the surface as a meteorite. To date, more than 50,000 meteorites have been discovered, giving astronomers a unique chance to directly study other places in the solar system. But to do that, they need to know where those bits came from. And while it's usually possible to figure out roughly where they came from, like, say, from an asteroid or from Mars, pinpointing their exact origin is virtually impossible. Except in June 2018, we actually did. In a remarkable feat of forensic astronomy, scientists managed to trace one meteorite all the way back to the exact crater from which it came, more than 200 million kilometers away. On June 2nd, 2018, astronomers at the CATALINA Sky Survey in Arizona spotted an asteroid headed for Earth, which was a really big deal, because it marked only the second time ever that astronomers spotted an incoming rock before it hit Earth. At 1.5 meters long and with the mass of an African elephant, this rock wasn't going to pose any danger to the planet. But it was big enough to likely make it to the surface, and by detecting it early, astronomers could predict where on Earth it would fall. Based on its trajectory, the team predicted it would make landfall somewhere in a 3,500 square kilometer area of Botswana. On one hand, amazing. On the other hand, though, that doesn't exactly pinpoint the location. But hey, they were right. The asteroid burned up and exploded about 30 kilometers above Botswana's central Kalahari game reserve. Almost immediately, meteorite hunters were on the case, searching for surviving fragments of the explosion. The whole effort was shockingly like a Hollywood spy film. Some of the researchers studied gas station and hotel security camera footage for clues, while others scoured the game reserve under the protection of park rangers. By the end of the search, 23 fragments had been found, each weighing from half a gram up to 20 grams. The meteorite was named MOTOPI Pan, after a local watering hole. Once scientists got those shards back to the lab, they could begin the tricky forensic task of figuring out where they had come from. Like more than 99% of meteorites that fall to Earth, it was clear from its stony composition that MOTOPI Pan had come from the asteroid belt. NASA has been particularly interested in asteroids in the 21st century, with several current and future missions studying these building blocks of the solar system. And back in 2007, NASA launched the Dawn probe to study the asteroid belt's two largest objects, the dwarf planet Ceres and the asteroid Vesta. Dawn spent 7 years orbiting Ceres and Vesta, studying their geology and landscape in unprecedented detail. When planetary scientists compared that data to the meteorites we have on Earth, they found evidence of a remarkable connection. More than 2,200 meteorites picked up here on Earth were a direct match for Vesta's chemical composition. And after its landing, researchers quickly matched the composition of MOTOPI Pan to Vesta too. But here's where the story of this meteorite diverges from the typical path. To back up this geologic evidence, astronomers reverse-engineered the asteroid's trajectory based on the Catalina Sky Survey's sighting before it hit Earth. They confirmed that, yes, it had in fact come from the direction of Vesta, but they could go one step further and figure out the asteroid's flight time too. Prior to being blasted off of Vesta, the minerals that made up MOTOPI Pan would have been buried deep underground. But once they were exposed to space, their chemistry became subtly altered by interactions with cosmic radiation. The longer they were exposed, the more the damage would build up. And because MOTOPI Pan was collected so quickly, that evidence wasn't disturbed by weathering here on Earth. A research team studied its radiation damage and calculated that the rock had been traveling for about 22 million years. Remarkably, knowing how long ago it departed the asteroid belt also helped scientists to pinpoint more precisely where on Vesta this chunk of rock came from. The data from Dawn also included detailed maps of Vesta's terrain, from which scientists were able to reconstruct the age of craters on its surface. So they found an ideal candidate for MOTOPI Pan's departure point in a 10-kilometer long crater called Rubria, with an age of about 22 million years. This crater sits on a stable hillside near Vesta's equator, in an area that's otherwise unaffected by landslides or other erosion. That fits with MOTOPI Pan's surprising lack of contamination, suggesting that the rock had sat undisturbed beneath the surface for billions of years before an impact on Vesta tore it out and sent it on its way. There are definitely some assumptions involved with linking MOTOPI Pan directly to Rubria, but as we've seen, there's also a remarkable amount of evidence. Meaning, and I cannot say this enough, astronomers were able to trace the rock not just from the asteroid it came from, but probably to the exact spot on the asteroid it came from. And with careful observation, they hope to do it again. If they can use a combination of telescopes, meteorite hunters, and spacecraft to track more meteorites back to their source, that'll be a big step towards decoding the forensic mysteries of the solar system. Those astronomers needed to know how to understand and analyze their data. And in today's world, so do the rest of us. DataCamp can help you learn data science with over 350 courses and interactive learning experiences. They've even got a whole course about data analysis in Microsoft Excel, where you'll work with real-world data and learn to, well, Excel. The lessons are bite-sized and can fit your schedule. Their mobile version also allows you to learn from anywhere. If you click on the link in the description, you can check out the first chapters of each course for free. So, thanks for the support.